Alrighty. 2020, Exam 2, Question 3. Let's chuck that document in the chat so you can have your own copy. It is screen sharing, yeah it is. Nice. Yeah. Let's crack into it. The transport company has detailed records of all its deliveries. The number of minutes a delivery is made before or after its scheduled delivery time is normally distributed. Mean of 0, standard deviation 4 minutes. And we even have a graph to help us out a little bit. Probability of t less than or equal to a is 0.6. What is a? Fairly standard question to start us off. I'll give you a moment to collect your thoughts. Yep, totally fine. So normal distribution. There's a couple of things to keep in mind with normal distribution. There's only two real CAS functions to work with for it. So let's have a look at them. Normal PDF, well, I guess not really even. Yeah, normal CDF and inverse normal. Those are the main ones you're using. Normal CDF you use whenever you want to find a particular probability. In this case, we're given a probability, so we're not trying to find one, so CDF is out of the question. That means that the inverse normal is the next thing that we should be considering trying to use. So if we have a look at that, we'll see we have to give a few options. We've got area, we've got mean, and we've got standard deviation. Mean and standard deviation, they're going to be very easy. You just take them from the picture, from the question. Mean was 0, standard deviation was 4. The only thing that's a bit interesting that we have to consider is area. TI Inspire has a particular way you have to do this. Casio you can do whichever way you want. Do you know what this could be potentially talking about? Anyone? 1 minus 0.6. Yeah, so if you need to flip it, you would do a 1 minus. With the TI Inspire, you just got to know that it always points left. And so in this case, we do have t less than or equal to a. That does mean we're pointing left already. So for TI Inspire specifically, we will keep this one as 0.6. For Casio, you can actually pick, oh, whoops, that's strange. For Casio, you can pick whichever way you want it to go. You'll pick either the left, right, or center. Center's a fun little thing that we pretty much never use, unless there are certain circumstances for it. But I'll show you that for Casio. Let me see again, it's in distribution, inverse normal CDF, and I clicked the wrong one. Obviously that would have worked, but I'd rather you see the interactive. So basically you can set your tail, whether you want to point left or right. We'll ignore the center one unless it comes up because it's very rare. Probability is the same thing as area, and then, well, standard deviation and mean, as we saw from earlier. So we got the value 1.01. We're trying to do it to the nearest minute. Remember that our x-axis is in terms of minute, so we're just going to bring that down to just 1 minute. And so yeah, we're just going to give a equals 1 for that circumstance, or for that question, rather. Any thoughts? Anything to clarify? If not, feel free to move on to part B. Definitely spend some time to get your head around the scenario. This is the number of minutes a delivery is made before or after its scheduled delivery time. So a mean of 0 means it arrives on time. Any positive number Yeah, okay. That's a bit tricky. Positive, I don't really define it, do they? Kind of before or after. Pretty sure the intention is positive is early and negative is late, but that's poorly defined. Yeah, okay. Is it? Hang on. Before or after? What do they actually mean by that? Let me just check the answer real quick so we can be clear on that. No later than 3 minutes after. Positive meant after scheduled delivery time. Huh. Yeah, I mean, that wasn't my intuition on that. My intuition would have been that positive means good and negative means bad. We'll go forward with the assumption that this is minutes after delivery. So positive means it definitely is minutes after delivery. Negative minutes after delivery means it shows up earlier. So being no later than 3 minutes after scheduled delivery time means that you don't want to be above, like from here. We're saying no later than this. So we're not ever reaching this part of the graph. Technically, it starts earlier at 3, but 3 onwards, given that it arrives after. So the conditional is all of this. It does arrive after, and then no later than 3 minutes means it's in this range in here. That's what's being talked about there. There's not even a, I'm looking at the exam report, there's not even a recognition of people who might have got it back to front. Strange. Anyway, hopefully that's clear enough what has to be the case now. If that needs to be clarified any further, let me know. From there, we just need to be aware of what the conditional probability means, right? No later than 3 given after scheduled delivery time. We got to figure out what does that conditional probability equation actually look like. Once you have that, actually calculating the probabilities that are related to it, that's not so bad, but we just need to know what we're actually aiming at. For those still catching up, that would be the conditional probability formula. It'll be the intersection of these two inequalities and then divided by whatever the conditional is. So you want to figure out from 0 to 3 and then all x greater than 0. So because those are both probabilities, you want to find a probability. There's one CAS function that definitely helps you out with that. There's even a bit of a shortcut you can use actually. Probably x being greater than 0. Well, if 0 is the mean, then this just means probability of being right of the mean. And so that one's guaranteed to be 0.5. We don't even have to do a CAS CDF for that. We can just leave it as 0.5. But we are going to need a CDF for this one. Any luck, or you want me to walk through it? Okay. So we're trying to find that CDF on the top, probability between 0 and 3. As I said at the beginning, normal CDF is the way to go for probabilities within a given domain. We're trying to do from 0 to 3. That's going to set our lower and upper bound. Mean of 0 as before, standard deviation of 4 as before. That's going to give us 0.27 for the numerator. We're just going to divide that by 0.5 to get our 0.547 rounded to 3 decimal places. If you then didn't spot that 0.5, that simplification of 0.5, sure, you can go ahead and do your 0 to infinity of the exact same thing, and I mean, it's basically a rounding error at that point. If you do the exact same division, like, it's accurate up until a lot of decimal places. So even if you did do it that way, you're still not really all that out. Fair enough on how that all works. Let me know if anything needs clarifying. We'll move on to part C. Using the model described on page 19. So the exact same normal distribution we had earlier. The transport company can make 46.48% of its deliveries from -3 to 2. It has an improved delivery model with a new mean of k and the same standard deviation. Find the new possibilities of the mean, because the mean is k, so that 46.48% is made over the interval -4.5 to 0.5. That's curious. So we're trying to figure out what k values would take us from having 46.48% between -3 and 2, and now shifting that to be -4.5 and 0.5. One of the easier ways of going about this would be to get a picture going. We kind of already have a picture, so in the real exam you would probably be drawing something on that. Here we're just kind of gonna eyeball it, which is not hard at all. You just draw a little bell curve. We're going to keep it set, at least if we draw the initial scenario, set it a mean of 0, and then -3 to 2, so we're going to have our -3 here, our 2 over here. This is, quite quite excessive, this one's supposed to be 46.48, which is clearly not depicted, but we are just sort of eyeballing where the index, where the ticks would be. You can see on the actual thing, -3 to 2 is quite a small domain. And so yeah, we're told that key piece of information there, 46.48, is between those two probabilities. Now, what we want to have happen is that same probability between -4.5 and 0.5. So if we draw another one, maybe this one can be in red so we can more clearly distinguish between what's going on. -4.5 to 0.5 minus 4.5, some mean of k, 0.5. Maybe I'll shift this further out so it looks a bit more to scale. That should now be 46.48. We've got to figure out what values of k would cause that. My initial thought of values is a bit interesting because you'd almost expect just shifting left would do the trick and that'd be it, pretty much. Like, you know, from -3 to 2, shifting this one left would make it -4.5, so shift left by 1.5, shift left by 1.5. You know, that would give you a nice and easy k value of -1.5. But it does say values plural, which is curious. That's the obvious approach there. What else could potentially work? What else could we do? Possibly mess around with the Z stuff. You could, yeah. So if it's 46.48 dead center, oh, not dead center really, but 46.48 in here, then everything out is going to be 1 minus that. The challenge is it's not quite, well, no, we do have standard deviation. So let's think about what we have and what we don't. We have Z values. Oh, sorry, we don't have Z values. What am I saying? We have X values. We don't have the mean. We do have the standard deviation. We have two separate things. We could get Z's out of this. This should just be a simultaneous then. So, oh what? Let's try one. Z1 can be the left-hand side thing. You got -4.5 minus k over 4. And then Z2 would be 0.5 minus k on 4. Two equations, two unknowns. It's just a simultaneous equation solved now? No, because it's not two unknowns, it's 1, 2, 3 unknowns. So with that in mind, might have to do something with the inverse normal here.
Chris, I think the CAS cannot solve systems of equations like
It can, yeah, but just because these both say Z doesn't mean they're the same Z. That's the issue. You've got variable 1, variable 2, variable 3. So we would actually need 3 equations if we're going to do a system of equations. And that's the main issue I'm having here with it.
Right.
Now, so if we can't get a third equation, we probably can get a z. I just got to think about it because we have this 46.48% thing that we haven't used, haven't done anything with. So if that's 46.48, then collectively either side is going to be 1 minus that. Um, do. Well, I guess Z is directly tied to standard deviation. Like, for instance, if this was -4, then that would just mean Z equals -1. So we could actually get our Zs. So you got -4.5. So what are we doing here? -4.5 divided by 4. That's going to get us -1.125. And then that's, I mean, that should be an easy solve right there for one of the k values. I'll be curious to see if we do both of them, that we get two separate possibilities. So you got that one is equal to -4.5 minus k over 4. Okay, maybe that's it. Let me just check real quick. That's not any of them. Oh, right, because I said a 1 instead of a 4. How'd that happen? Huh. Now what? -4.5 was one of them, and that corresponded to -1.125 for a z. X minus k over 4. I mean, a equals 0 was not one of the solutions. Maybe I'm just trying to force it. So I did actually see the answer that was prescribed, which was very weird. You don't actually use the normal CDF or the inverse normal for that matter. What they did was they used the definition of the normal distribution itself, and they used the integrals, which is very, very uncommon. I was trying to avoid using it because it's like, if you can get away with it, you probably don't want to use it. And so what they've done is they've said, okay, the CDF is still the normal CDF is still fundamentally just a continuous probability thing, and so we can treat it like continuous probability. We just need to have the normal distribution function in our bound reference. This is a tech active after all, so we can have it in there. It wouldn't be the end of the world to do it, but far from typical. So we're just going to put in what that actually is. So standard deviation goes as a coefficient before the root. Then you've got e to the -0.5 bracket, all of that squared. And then this is your x minus the mean, so k, over the standard deviation once more. Just going to double check I didn't miss anything else. Looks good. And because we're treating it like continuous probability, we know the integral from 0.5 to -4.5, we're told that is 46.48, or in decimal you got 0.4648, comma k. Wait for it to do its thing. There is a decimal there, it just doesn't show up on the screen very well. This is the other issue with that, which is that it takes a bit of time for the CAS to figure itself out. But it does give us the two options that were prescribed. the negative 1.5 that we figured out from earlier, and then the negative 2.5, which honestly doesn't make a whole lot of sense to me. I don't really know how that's possible, but just sort of thinking about the raw shift from one to the other. But I guess both is somehow possible. No, maybe actually, because there's yeah, no, I guess that makes a decent amount of sense because they decay. Because it's not a symmetrical thing, it'll decay at different rates. Like if you shift it closer to the mean on one side versus the other, it'll depend on whether it's going to be left dominant or right dominant, as far as like where the bulk of the probability is located. So yeah, I try to find a nicer way of doing it, but I guess sometimes you just got to brute force it with the integral. Yeah, so at the very least, one of those marks should have been easy enough. If you use very similar tactics to what we're already used to, you just draw your two things and you realize, oh shit, I can just shift everything left by the same amount, and then, well, I should have the exact same distribution. That gets us our negative 1.5 as a possibility. So you at least get a mark off of that. Then the other one's going to come from knowing somehow that you're supposed to use integrals. It was a 6% pass rate to have the whole thing. So yeah, quote, many students did not find k equals negative 2.5. Shocking. Wonder why that could have been. Anyway. A rival transport company claims there is a 0.85 probability that each delivery will arrive on time or earlier. So if we think about the same distribution, on time or earlier just means either x equals 0 or in the negative direction. And we got a very high likelihood of that occurring. Assume each delivery is independent. If the claim is true, find the probability that on a day where there are 8 deliveries, fewer than half arrive on time or earlier. I won't say anything specific other than be alert. Something's kind of changed here. It has changed into a binomial. Absolutely, it has. We are looking for a probability. So what are we going to do to get it? Or just what is the answer going to end up being? They have worded it in a bit of an interesting way where they're not making it super obvious what the well, super obvious what the parameters are going to be. There's all of our binomial options, A through D. 0.003 is going to be correct on that one. So that would have been a CDF. You would have had your number of trials of because 8 deliveries. Probability of success was given to us as 0.85. Lower bound would be 0 because you're looking for fewer than half. And they're saying half of them. Half of 8 is in fact 4. And because you want fewer than 4, you would set that bound to 3. And then, of course, round that up because we're doing it to 3 decimal places. And yeah, that's that one. Nice work. Part E. Assuming rival company. Yeah, okay. Once again, assuming the claim is true. This time we have n deliveries. So no longer 8, but n. Express in terms of n the probability that one or more deliveries will not arrive on time. So we're doing the opposite now. One or more is not going to arrive. Not really one you would do on the CAS all that much. Although maybe you could. one of the key things to understand here is that we flipped from arriving on time to not arriving on time. All of our probability distribution stuff is purely in terms of arriving on time. Like this one here, right? 0.85, but it does make it on time. 1 minus 0.5, yeah, correct, yeah. So you've noticed that you should just do the inverse, right? Which is one or more deliveries on time. You flip that. So you're doing 1 minus 0.85. Is that meant to be power of n, actually? It should be 1 minus, yeah. Yeah, cool. Yeah, exactly right. So you would have had to, hopefully, you would have had to simplify the Bernoulli sequence a bit on that one. But yeah, because you're doing one or more not arriving on time, you flip that to x being 1 minus x equals 0, and then because you got an x equals 0 in the Bernoulli sequence, all of it disappears. Nice. 1 minus 0.85 n. Hence or otherwise, find the minimum value of n such that there is at least, okay, we've done a lot of these. Finding n to guarantee a certain probability, one or more deliveries will not arrive on time or earlier. There's probably two easy ways you could do this. There's the hence version. 18.43, round up to 19. Yes, round up to 19. That's it. What method did you have going on there? Did you use the equation or something else? Yeah, algebra solve equation. Easy. So algebra solve equation is literally just grab that equation that we had and then inequality. At least 0.95 means greater than 0.95. So we go a31 1 minus 0.85 power of n greater than 0.95 comma n. Whoops. And then, well, if you want to be greater than that particular value, then obviously you want to round upwards. Crushing it. Part F, a whole bunch of nonsense. Let's see. I just took a sneak at the answer there. 3% pass rate, my god. Well, let's find out. Analyst from a government. It's only going to be true for deliveries made before 4 p.m. If deliveries made after 4 p.m., the analyst believes it's actually going to be... Wow, the probability is anywhere from 0.3 to 0.7. Okay. So they've used x, but x is a probability in this case, not on the x-axis. So that's a bit cheeky. After observing a large number of the deliveries, the analyst believes the overall probability, so broadly speaking, we've got a 0.75 chance of arriving on time or earlier, which is pretty damn close. They were almost accurate. Anyway, let the probability that a delivery is made after 4 p.m. be y. So... Okay, what? Deliveries made after 4 p.m. Delivery made after 4 p.m. Probability of that is x. Probability of that is y. They're talking about the same thing. That's kind of nasty, but sure. Find the minimum and maximum values of y. So yeah, okay, sure. We got a whole bunch of information in there. Let's see what we can do to decipher it. Anyone spotting anything that could get us started? I can think of at least one thing that can help us. We can put that into an equation of some sort. How am I actually going to define this? On time or earlier, so I guess it's just got to be careful with using x's because there's already x's in the thing. I guess we say PR capital X less than or equal to 0. Because remember that negative means it's earlier. That's 0.75. Now, we've got to remember when it comes to the rival one, we're not dealing with a normal distribution anymore. We don't have a whole lot of information about the rival company. The original one was normally distributed. The rival one was binomially distributed. So we got to remember to use binomial methods for this particular thing. So for probability of x less than or equal to, well, hang on, that means we've got to change this up because we're not using the normal distribution thing. So on time or earlier, okay, so that's just p then if it's binomial. P is 0.75 because that's the population proportion, the global thing there. And then what? So we've got a few conditional probabilities in there. Before 4 p.m., so probability of on time given that it's before 4 p.m. is 0.85. Yeah, I think that's right. Probability on time given before 4 p.m. That's when it was true, right? It was true means 0.85 for that, which means we can make that the conditional now. So probability of on time intersecting earlier than 4 p.m. over earlier than 4 p.m. than 4 p.m. On time or earlier, and earlier than 4 p.m. just intersect to being on time or earlier, since they're both pointing in the same direction. So really it's just probability of on time divided by probability of being less than 4 p.m. We told anything about the likelihood of whether it's before or after 4 p.m.? Not really. We could find it actually, because probability of on time, that's this 0.75. And let's believe the overall probability of on time or earlier. Yeah, okay. So now we have 0.75 over all that is equal to 0.5. Sorry, 0.85. I don't know how that changed. And then that is a fairly easy quick CAS solve there. So let me just do that. So 0.75 divided by 0.85. So that means the probability of a delivery less than 4 p.m. is going to be 0.88-ish. Okay. Probability of delivery being made after 4 p.m. is y. Okay, well that's going to be a bit weird. Because if we just said that this is the probability... If we just said this is the probability of being earlier than 4 p.m., then probability of being after 4 p.m. should be 1 minus this, which would set a specific value for y, which we don't want. We want the minimum and maximum. Maybe we need to look at this one. Deliveries made after 4 p.m. It's going to be anywhere from 0.3 to 0.7. Yeah, I don't know. I mean, I could keep stabbing at this, but I feel like I'm just going to waste everyone's time. These are the kinds of things I would have been doing. Maybe even get like a tree diagram going. So you have whether it's before or after 4 p.m. This will be, let's call that one before, let's call this one after 4 p.m. And then you've got on time or not on time. And what I was going to start working towards was putting, well, okay, probability of on time. Maybe that was the issue there, actually. I can't put this there because probability on time means adding these two things together. Maybe that might have been the issue. Either way, you go through this procedure of trying to put things on a tree diagram, and from that you could probably work your way towards getting your y values. But the probability of delivery being made after 4 p.m. is y, so you're looking to get some stuff in here. Yeah, after class I'll have a look at that, see if I have a better answer for it. I'll make it as a post if I figure it out. I'll probably figure it out, even if it takes a day or two. Okay, next up, question 4. Slope of tangent at x equals 1. That's a freebie. Who's got that one going? Solve it in a very similar, yeah. -2 for slope. Yeah, -2 for slope. That's it. That would have been derivative and then subbing in x equals 1. Derivative, h of x. You could go ahead and define it if you want, but it's probably quick enough to just chuck in your x equals 1. You get your -2. No units, just slope. So that's easy enough. Find the obtuse angle. Yeah, okay, so just convert it to an angle now. Specifically the obtuse one, though. Well, it won't be too hard to figure that one out. Which one should be which? There's only one real way you can go about getting angles from gradients. And so if we think about what's going on, you've got your curve, x equals 1, gradient -2, so we're at least over here, we know that much. Draw some kind of tangent off of that. Now it says makes with the positive direction of the x axis of the horizontal axis. You've got this. Well, you've got this, I guess. What they're talking about? Has to be. It's got to be either that one or that one. One of the two. And so yeah, we just got to figure that one out. How do we normally get angles from gradients? Yeah, tan inverse. Absolutely. So we'll do exactly that. Tan inverse of gradient, and then convert the decimal. So let's just make that the settings. I'm not so privileged to have a button that does it immediately, like the newer cars. Cool. So we got negative 63, which is not particularly great. Negative 63 would imply that we got this in here because it's in the negative direction.
Is the answer 153?
153 is a bit big. How'd you get that?
So like you know how we have the slope of the tangent, right?
Yeah, yeah,
Negative 2x. I got the full line anyways, negative 2x plus 4.
sure, yeah.
So I basically just drew a triangle with the base being 2 and then the height being 1 and then putting an angle in there for theta.
The
And
base being 2. Gradient's got to be negative 2, though. I don't know, that might play a role.
right, like
Yeah,
it's kind of hard to explain.
yeah, yeah. So you got like this,
Yeah.
basically, yeah?
And the bottom is 2 and that's 1 because that's basically like how
Yeah,
the
yeah,
like function moves, right?
sure.
The bottom right, I put an angle there,
Hmm.
and then I just did tan inverse of 1 on 2, like tan negative 1, bracket 1 on 2.
Yeah, okay.
And then I thought that would be like supplementary to the actual angle, the obtuse angle.
So we're supplementary. Yeah, I mean, let's did you say you did tan inverse for this?
Like, you know when you go into the trig functions and then
Yeah,
you have
yeah,
like
tan to the power negative 1.
yeah, tan to the power negative 1.
This would be Sokotoa, wouldn't it?
Right.
SOH.
Um, so 1 on 2, because opposite over adjacent.
Yeah. Yeah, okay, because you got the opposite, you got the adjacent. Yeah. So, yeah. 1 on 2, tan inverse. Tan inverse 1 on 2. Well, tan inverse 1 on 2 got you this, 26, and then what you did, 180?
Yeah, 180 minus 26.
180 minus 26.
I mean, it's 27 because you got to round to the nearest degree.
Hmm. Yeah, I don't know why that's off. Um, I don't know what's off about that. The intended solution is just go, you've got this tan inverse of negative 2 because you've got that gradient, and then you just add 180 off of it, because that flips it to what you're looking for, and that's what should come out. I don't really know why that didn't come out fine. Probably something to do with the fact that you've got tan inverse of a half. I don't know what's up with that. Oh, hang on, you got the triangle back to front.
Oh, do I?
That would describe a gradient of a half. You want a gradient of 2, or I guess negative 2, but
Oh,
yeah.
okay, yeah, I see. So we have to do tan inverse of 2.
Yeah. Okay. So no, you had the right idea. You just all roads lead back to tan inverse of negative 2.
Yeah, all right. So
Yeah, okay.
we should get like what, 117?
Yeah, 117 is what we're aiming for there. Yeah. All right. So our ideal is fine. We just had the numbers in the wrong spot. A little bit.
All right, my bad.
No, you're good. Cool. That's that one. Next up, find the slope at point P. Okay, so that's also pretty much free. The CAS gives that to you. What will we do? Yeah, you could do it a couple of different ways actually. We don't have x equals 1 anymore, we just have x equals P.
Did we just do derivative and sub in P?
Yeah, that sounds appropriate to me. Derivative and then sub in P. What did I call it? Probably H. Yeah, okay. Derivative H. Probably just could have grabbed it, but whatever. And then put P's in those spots. So basically nothing's really going to change. Just imagine the P instead of X. Yeah. That's one way of going about it. The other, which I typically default to, would be to get the tangent line. So go to the CAS tangent line function and then read it off of that. So comma x, comma p, and then you just read off of the gradient term. Those are going to be the same thing. But at least that way you also now have the tangent line that you can work off of. Because usually they follow up with a tangent line question afterwards. In this case, probably not super helpful in this case, but in a decent number of other circumstances, it's good to have. di, find the value of p for which the tangent at x equals 1 and x equals p are perpendicular to each other. Okay, that's going to be fairly nice. Got to figure out what's the key thing about perpendicular lines. How can we tell? And then effectively reverse engineer our way back to where the x would have to be to force that to happen. You got x equals p. Solving for p is basically just solving for x.
Chris, I got two solutions for this.
Okay, sure.
Is
What'd you
one of
get?
them 0.655?
0.655 is, we'll say one of them, yeah. It does say find the value of p, so if you got two, you're going to have to cancel one of them.
I'm guessing we have to cancel because I got negative 0.655 as well.
Mm-hmm.
Guessing I need to cancel that one because there's exponentials involved.
We have to cancel that out, and if so, why? So you want to have the negative reciprocal. So it was a gradient of -2. You now want it to be positive a half by flipping it, and so you just make yeah. Let me just see what you're saying, I guess. We'll grab that. This was the gradient. Want to equal to a half, and want to find out what's going on there. That gives us two possibilities. Is there a restriction on P? Oh, because it's flat out a negative x value. Yeah, it's not defined from anywhere from 0 to 3. Oh, anywhere outside of 0 to 3. So yeah, that's all that was. Yeah, so you cut off the right one. Nice. Yeah, I do actually have one thing that might have helped with the previous question. I don't know if I ended up writing a solution for it, God knows how long ago or not. Let's see if I did. I forgot I have some solutions to this from about a year ago. What's this? So this would be 3f. Do I have a 3f? I do. Okay. So, oh sure. Okay. So there's a little Carnot table that you can work with. The y1 minus y, the 0.75, the 0.25 for the basic times of like basic things of on time and late, before and after. Using conditionals ended up being right. Assigning it to x because of this. Okay, so I got something in there, I guess. This probably isn't published, actually, so let me put that in the looks like shit. It's not published, but I'll put it in the chat anyway because it'll be better than nothing. I apparently had an idea, and this was the correct answer. So I guess the ideal approach there was work with Carnot tables and work your way back from that. I know it looks a bit messy, but I'll tidy it up at some point. I'm working on them. So cool. At least now you'll have one to read, so I don't leave that as an open loop. Cool. And then with the last minute, find. Wait, we already did that. Find the value p, hence find the coordinates where the tangent at x equals 1 and x equals p intersect when they're perpendicular. Okay, so this x equals p thing, that told us where do we take the tangent at. So we can't actually say that this is the x coordinate of the intersection point. That's just where you take the tangent off of the curve. Like for instance, if you took a tangent from here and from here, those are the two x coordinates that you took them from. Where they intersect would be somewhere like out here, perhaps. And just to speed run through that a little bit, basically you want your two tangent line equations. So basically what I just did there, but with x equals 1 and x equals p, you've got the first one if you did this method from before. You copy this down for x equals 1, make them equal to each other to get the x. So that equals that, comma x. And then 2 decimal places, so you can just do that. Is it not gonna... Oh, right, because x, right. I should probably put a p in there instead. Oh, no. No, because we know what p is actually, sorry. That's what the issue was. We go through and grab this p value. Fine. That'll fix this up. I'll enter. Yep, cool. And then just shove that back into any of the functions. Doesn't matter which. Obviously, one is going to be significantly easier than the other. And that'll get you the corresponding y coordinate. Dunzo. Yeah. Anything to clarify, let me know. Hopefully those solutions explain a decent amount of that previous question, because that was a tough one. I'll leave you to it. No worries.